Hello, my friends. I hope that you are all doing well today. My name is Natalia, and I am an educator with the Cincinnati Observatory. Now, if you've been to our YouTube channel before, then you've seen we've talked a little bit about the solar system. We've talked about deep space. We've talked about stars. But we have yet to talk about the space body that is actually most important to life here on Earth, and that is the moon. So let's talk about it. All right. So if you can imagine sitting on the surface of the moon, staring out into outer space, you would probably notice that the Earth looks pretty big. And the reason that it looks so big is that the moon is only 1/4 of the size of Earth. And that sounds pretty small, but actually the moon is the largest compared to its host planet of any of the moons in the solar system. You would also notice as you moved around on the moon that it's a lot easier for you to jump up high. It may be a little bit harder for you to walk normally, and that's because the moon only has 1/6 of the gravity that we have here on Earth. Now, hopefully, while you're on the moon, you have a really good spacesuit that can protect you from a wide range of temperatures because the moon has a really thin exosphere instead of having a thick atmosphere like we have here on Earth. And this makes you a lot more vulnerable to the power and radiation that comes from the sun. On the moon, during the daytime, temperatures can get up to 260 degrees, but during the nighttime, temperatures can drop all the way down to negative 240 degrees. With that wide of a temperature range, you're going to need a really, really strong spacesuit. Now, many of us are familiar with the fact that the moon is covered in craters, which are all from space rocks that have hit the surface of the moon. But the moon also has all of this dark material across its surface. And a long time ago, people used to think that these were actually seas. But samples from the Apollo mission showed us that this is actually all dried up lava. So you may be thinking, well, is the moon covered in volcanoes? Not exactly. Now, if we're going to talk about all of the lava on the surface of the moon, then we need to go back in time about 4.5 billion years ago when both the Earth and the moon were practically brand new. This was an era called the Late and Heavy Bombardment, when both the Earth and the moon were continuously pummeled with space rocks for hundreds of millions of years. These rocks that hit the Earth and the moon ranged from asteroids to pieces of planets that never ended up fully forming at the birth of the solar system. So then this begs the question, why is it that the moon is still covered in craters from the late and heavy bombardment, but the Earth is not? And the reason for this is that the Earth both has plate tectonics and weathering that is constantly renewing and changing the surface of the planet. However, the moon does not have these things, and so because of that, it is still covered in craters to this day. But this doesn't answer the question, where did the Maria come from? Well, some of those space rocks hit the moon so hard that they actually cracked the surface of the moon, leading to magma pouring out onto the surface. And this is what created the Maria, all of the dried up lava that we see on the surface of the moon today. But why should we care about the moon? Obviously, we know that the moon looks beautiful in our skies, and the more that we study the moon, the more that we learn about the history of Earth. But did you know that the moon is an important part of how life came to be on this planet? So just like the Earth's gravity has a hold on the moon that keeps it orbiting in our skies, the moon's gravity has a pull on the Earth as well. The moon's pull on the Earth stabilizes the Earth's wobble, creating our seasons. But you may be wondering, what is the Earth's wobble? Well, as Earth spins, it also wobbles back and forth on its axis in a process called precession. This wobble exists with or without the moon. However, the moon makes the wobble more stable so that our tilt only changes by a couple of degrees over the course of many years. Many scientists think that without the moon, our planet's wobble would increase anywhere from 10 degrees to 40 degrees. Even on the modest side, a 10-degree difference in our tilt could create massive changes in our climate, even potentially rendering the Earth uninhabitable. Imagining the Earth without the moon involves facing a planet that potentially has extreme changes in climate over the course of just a few years. Imagine that for a few years it is extremely hot temperatures, like potentially even over 100 degrees. And then a few years later, you experience moderate temperatures. And then eventually you get into an ice age. It would be very difficult, perhaps even impossible, for life to exist on a planet like this. But on top of that, the moon actually also slows down the Earth's spin. So, without the moon, the Earth would spin so much faster that instead of having 24-hour days, we would have days that are only 6 to 10 hours long. Now, most of us are familiar with the ways that the moon affects tides here on Earth. If the moon disappeared, our tides wouldn't completely disappear with it because the sun also has some pull on our tides. However, our tides would only be 30% as strong as they are now, which would decrease nutrient cycling in the oceans enough that it could have a detrimental effect on life in our oceans. Learning all of this information about the moon, you may realize that the moon is more complicated than it seems. But how did we get the moon? Will we ever be able to live on the moon in the future? Stay tuned for future videos about the moon from the Cincinnati Observatory. And if you are interested in what the observatory is doing, be sure to check out our website at www.cincinnatiobservatory.org. Have a good day.